Chalo. See the first side heading beta, phase difference. I already told you this one in the waves. The phase difference is represented by delta phi, and phase difference is being given by the formula delta phi is equals to your 2 pi by lambda into delta x. Delta x is known as what beta? Path difference. Delta x is known as a what? Path difference there, and delta phi is known as of your phase difference. So relation between both of them is how much? Delta phi is equals to 2 pi by lambda into your phi. Lambda is nothing but wavelength. What is the wavelength, beta? The distance between. So if I'm taking the wave like this right now, so this is your wave, this is your node, and this one is your node. The distance between this node and this node is known as of your lambda. The distance between this node and this node, half of that one will become for me lambda by 2. The distance between node and the anti-node will be equal to lambda by 4. Okay, so the distance between the phase difference and the path difference is given by the formula delta phi is equals to 2 pi by lambda into your delta x. Now let us try to talk about coherent sources. What do you mean by coherent sources? The sources for which omega is same, that is angular frequency is same. So those sources which have a constant phase difference at a given point and which does not vary with your time is called as of your coherent sources. Like delta x is equals to k into delta phi. Delta phi is equals to how much for me? K into your delta x. K is known as of your constant part and phi is remaining constant with respect to time. Like say on this screen, if a wave is coming from S1 and S2, S1 is taking x1 distance and S2 is traveling a distance of S2. If both of them are meeting exactly at the center where the phi value is 0, then we say that there is a constant phase difference between them. If they are meeting exactly at R, then phi value will be 90. If they are meeting above at a point of P, then it will be your 180 partition. Okay. Now see, for example, we got two planar monochromatic waves propagating in the same direction with amplitude A and as well as of your 2A, with amplitude of A and as well as of your 2A partition, and differing in a phase by your pi by 3, differing in a phase by your pi by 3 radians. Calculate the amplitude of resultant wave. Calculate the amplitude of resultant wave. So resultant wave formula is how much beta? A1 square plus A2 square plus 2A1 A2 into cos phi. Phi value is pi by 3, A1 is A and A2 is 2A. Substitute the value, simplify it, we are getting the resultant amplitude as root 7 times of your A. Okay. Now let us try to talk about constructive interference, destructive interference. What do you mean by constructive interference, beta? Constructive interference, this is nothing but of your bright point. Bright point. Same phase. Destructive interference means dark points. So for intensity, what is the formula beta? Intensity formula is IR is equals to I1 plus I2 plus 2I1 I2 into cos phi. Isn't it? For what value it is becoming for me maxima beta? Can you tell me? IR will become maxima when cos phi value is equals to, maxima. Maxima value of a cos phi value is how much? 1. For what value it will become 1? I told you phi is equals to 0, 2 pi, 4 pi, go on. That means phi is equals to 2n into pi. Where n is equals to 0, 1, 2, 3, 4, we can go on to. So in the same way, for path difference in constructive interference is delta phi is equals to k into delta x, or phi is equals to 2 pi by lambda into delta x. What is a k in beta? K is known as propagation constant in the waves and it is given by the formula 2 pi by lambda. So path difference means take out the value of delta x from this one. Delta x is equals to lambda by 2 pi into your phi. Okay, phi value already we know, that is how much for me? 2n into your pi. This pi, 2 and 2 will get cancelled. So we are getting as n into lambda. So path difference is maximum. For maximum path difference, very, very important beta. So delta x must be equal to how much? N lambda, where n starts from 0, 1, 2, 3. So where are the points at which we are getting the maxima? Means at x is equals 0, we get maxima. At x is equals to lambda, we get maxima. At x is equals to 2 lambda, 3 lambda, 4 lambda, go on like that one. That are the points where we are getting maxima. Like see in this diagram if you are seeing. So this is your point. Phi's value is equals to 0, isn't it? Then we are getting the maxima. So at point Q is known as of your central maxima. So if both of them are meeting at a point of your Q part, if the angle between them is 0, then that will give me the maximum phase difference, which is known as of your constructive interference or bright points. So bright points are formed in general formula is how much beta? Delta x is equals to n lambda, where n must be equal to 0, 1, 2, 3. These are the 2-3 points you need to remember in constructive interference. In constructive interference is happening at angle of your phi is equals to 2n into pi, and path difference is at a distance of your delta x is equals to your n into lambda, where n value in both of them is starting from your 0, 1, 2, 3, go on. So first maxima is formed at center maxima 0, then second maxima at a distance of lambda, third maxima at a distance of 2 lambda, fourth maxima at a distance of 3 lambda, go on like that. The same way, if I'm going for destructive interference beta, for destructive interference also called as of a dark point, IR will be the minimum. So when it will become minimum? When cos phi value is minima. That means cos phi minima value is how much for me? -1, isn't it? So phi value is equals to how much for me? Pi, 3 pi, 5 pi, 7 pi, go on like that one. So if I take phi is equals to 2n minus 1 into pi, then you start n is equals to 1. If I take phi value 2n plus 1, then you start again from n is equals to 0. That's only the difference you need to remember. Path difference formula is phi is equals to 2 pi by lambda into delta x. So delta x is equals to lambda by 2 pi into 5. This phi value substitute here right now. So what is that phi value? 2n minus 1 into lambda. So this lambda and this lambda is getting cancelled here. So delta x is equals to lambda by 2 into 2n minus 1. Where n is equals to 1, 2, 3, 4, go on like that one. So where we are getting the minima beta? At lambda by 2. That means 0 to lambda if we are getting maxima. In between somewhere here we are getting the minima. Again between lambda and 2 lambda, at 3 lambda by 2 we are getting dark point. 5 lambda by 2 we are getting dark point. 7 lambda by 2, 9 lambda by 2, 11 lambda by 2, 13 lambda by 2. Like that, that are the points where we will be getting the bright points and as well as of a dark point. Screen draw delta x, we're getting bright point beta. That bright point is known as for me maxima. That is known as of your maxima. We also call this one as of your central maxima. At central maxima, we get a bright point. Okay, then path difference in the 0. Next one, we are getting the bright point where beta? We are getting the bright point at a distance of your, if I'm taking right now for this one, yeah. Bright point is somewhere here. This is your bright point. Again, same exactly mirror image for that one beta. We are getting even the maxima exactly below of that one. So here is your maxima at a lambda. Okay. Now, you know that in center already you have the maxima, right? Now, you know that in between the maxima and the minima, in between the maxima, central maxima and minima, we are getting a dark point. So here is a one dark point and here is your one dark point. So alternately, bright and dark bands will be followed like this. So this will be a bright band and this will be a bright band. Again, there will be a dark point right now here. Again, there will be a dark band right now. So alternatively, dark and black. This is white and dark, bright point, dark point, white point, dark points will be forming. So exactly whatever is the thing you are getting exactly above that beta, then mirror image is in the down. Like say if above we are getting 4 maxima. You tell me this one, this is your axis. Here above I'm getting your 4 maxima. Below also will get 4 maxima. So totally how many maxima will be there, beta? How many maxima will be there? Can anyone tell me? Nara?
Yes, sir.
Any maxima వస్తాయి చెప్పండి 4 పైన ఉన్నాయి కింద కూడా 4 అంతే కదా ఇప్పుడు చూడండి దీంట్లో ఎన్ని మాక్సిమాస్ కనిపిస్తున్నాయి చూడండి ఈ సెంట్రల్ మాక్సిమాకి పైన ఒకవేళ ఎన్ని ఉన్నాయి 2 కింద కూడా 2 ఉన్నాయా లేదా
yes sir
సో టోటల్ ఎన్ని అయినాయి రైట్ ఇక్కడ 4 in central ది కూడా ఇంక్లూడ్ చేసుకుంటే center is also the maximum only na including the center it will become for me 5 that means here 4 plus and center here it will be equal to your plus 1 so it will be equal to 9 okay because center we always get the maxima point of relation so please make sure of that one okay so that was
sir, can you explain the before calculation again sir
which one better this one
yes sir
now see in this one see constructive interference this formula you already know IR is equals to I1 plus I2 plus 2 under root of I1 into I2 into cos phi now I need this value maxima ఈ value maxima రావాలంటే cos phi value should be maxima what is the maximum value of cos theta plus 1 అవునా so when we are getting the plus 1 maxima when I keep phi value 0 cos 0 1 cos 360 degrees 1 cos 4 pi 1 so if I'm taking go on like that one what is the general angle phi is equals to 2n into your pi if I take n is equals to 0 1 2 3 so these are the angle at which you are getting the constructive interference now if I'm talking about path difference for this one phi is equals to k into delta x so phi is equals to k value is known as 2 pi by lambda into delta x so I'm bringing the delta x out so delta x is equals to lambda by 2 pi into phi Substitute the value of the phi here, beta. So this value I'm substituting here. So that is how much for me? 2n into your pi. So this pi, this 2 and this 2 will get cancelled. So path difference we are getting what, beta? N into lambda. For constructive interference, we are getting the maxima. We are getting one general formula. Delta x is equals to n lambda, where n is equals to 0, 1, 2, 3, go on like that. And what is the value of your delta x? If I take n is equals 0, then we are getting the first maxima at your central maxima. 0 means what? Central maxima only, no? The next one is at the distance of lambda, we are getting first maxima. Like that, at 2 lambda, 3 lambda, 4 lambda, we are going on getting the maxima. Is it clear?
Yes, sir.
Yes, sir.
అదే విధంగా డిస్ట్రక్టివ్ ఇంటర్ఫియరెన్స్ కూడా డిస్ట్రక్టివ్ అంటే ఇన్ ద సేమ్ ఫార్ములా దిస్ ఫార్ములా రైట్ నౌ ఇన్ దిస్ ఫార్ములా when this will become minima, it will become minima when cos value is minima. Cos, what is the maximum minimum value of your cos? Minus 1. So for what value we are getting minus 1 means phi is equals to 180 degrees, phi is equals to 3 pi, 2 pi, 7 pi. If I go on keep like that, we are getting minimum value. So I'm developing a general formula right now here. Phi is equals to 2n minus 1 into your pi, where n values to start from your 1, 2, 3. If I take here 2n plus 1 beta, then you should start from n is equals to 0. In some books, you will be taking 2n plus 1 into pi. But make sure that if he's taking 2n plus 1, then you should start n value from where beta? 0. Okay, na? Don't confuse in that one, sir. 2n plus 1 this 2n minus 1 this it's only the difference between from where you are starting n. If I'm starting n is equals to 1, then you take 2n minus 1. If you're starting from n is equals to 0, you take 2n plus of your 1. Okay, now? Sure. Next one is path difference. Path difference formula is how much for me, beta? Phi is equals to 2 pi by lambda into delta x. So delta x is equals to lambda by 2 pi into 5. I'm taking the delta x out. So delta x is equals to 2 pi by lambda, 2 pi by your 2 lambda into your 5. 5 value is how much for me, beta? 2n minus 1 into your lambda. Antena? Is it clear?
Yes, sir.
So delta x, how much I'm getting? Lambda by 2 into 2n minus 1. If I'm starting n is equals to 1, 2, 3, 4, go on. So delta x is equals to lambda by 2, 3 lambda by 2, 5 lambda by 2, 7, go on like that one. So if I take that one on the screen and see, we are getting at the center x is equal to 0, a bright point, which is called as of your central maxima. And second, first bright is being found at your this one. So this is known as of your first bright. This is known as of your first maxima. Okay. And this one is also your first maxima. Downward. Okay. And this one is your second maxima. Delta x is equals to 2 lambda kada. We are getting what beta? Second maxima. Okay, so then here this one is at the delta x is equals to 2 lambda. We are getting second maxima. Okay, so this is first central maxima, then followed by first maxima above, below, and second maxima and second maxima. So how many maximas totally? 1, 2, 3, 4, 5. అంటే సెంటర్ నుంచి 2 ఉంటే కింద కూడా 2 ఉంటే పైన కింద పై above is 2, below is 2, so 2 plus 2 4, including the central one, that will be equal to your maxima. Okay, then we are getting the minima at a dark point. This one is the first minima. This one is nothing but of your first minima, and this one is also your first minima, above and below. No? This one is your second minima, and this one is also your second minimum. So totally how many minima we are getting, beta? 1, 2, 3, 4 minima. Clear? Sure. If intensity is same, beta, I told you already the formula. The formula is coming out for me how much you see in this one. If intensity is same, so you take I1 is I, I2 is also I into I is also I, so that will be equal to I square. So root of I square means it will become I. So 2I will become common, it is 1 plus cos theta. So it is 2 into 2 cos square theta by 2. Theta is here nothing but 5. So it is 4I into cos square 5 by 2. So the intensity, resultant intensity, when both the waves are having same intensity, is given by the formula 4I into cos square 5 by 2. Clear?
Yes, sir.
Sure. If I is 0, I max value will be equal to 4i, and if I is 180 degrees and I minima is equals to 0, that is known as of a dark point. So for maximum intensity, we are getting it 4i. If I take cos y value 0, isn't it? So it is 0 divided by 0 is 0, cos 0 is 1, so we are getting maximum. So we are getting bright point I maxima is equals to, what is intensity at the central maxima? 4i. And exactly at 180 degrees, intensity is minima, that is nothing but for me, 0. See this problem better. Two coherent monochromatic light beams of intensity I and 4i are superposed. What will be the maximum and minimum intensities? I max will be equal to root of I1 plus I2 whole square. So I1 is your I, and I2 is nothing but how much? 4i. So we just simplify it, we are getting 9i. And then I minima is equals to root I1 minus root I2. I1 is I, I2 is 4i. So it is root I minus of 2 root I. So that will be equal to your I. So maximum is nothing but equal to your, maximum is nothing but equal to 9i. Maximum is nothing but equal to your 9i. And minimum is nothing but your I. Okay. Sure. Next one is Young's double slit experiment, which is actually very, very important for your competitive examination. In Mattam chapter, this is only the area where we get a lot number of questions for your competitive examinations. Beta. YDSC. What is a YDSC beta? Who is a whom? A Young part. Young told that Young is a scientist beta. He told that Newton initially what did he told? Newton told that light always travels in the form of your corpuscles. Light always travels in the form of what beta? Corpuscles particulation. Then later on, right now, the Huygens has been performed that it is in a wave nature, but he couldn't able to give the explanation for that one very detailedly. So Young developed an experiment to prove that the light is nothing but is having a wave nature. The light is nothing but you're having a wave nature. He proved the wave nature of a light by his experiment called as of your YDSC. In this one, he took the two coherent sources S1 and S2 from a single parent source. How did he got it? He took a single monochromatic light of wavelength lambda, and in front of this one he kept a cardboard, and to that cardboard there are two pinholes has been kept. So light started moving from that part. The moment the light started moving from the pinholes, it started bending. You know that light will bend only if it is having the wave nature, otherwise light always travels in a straight line. So the moment the light was been passing through the holes, it was bending and it was being incident onto the ground in the form of your bright band, dark band, bright band, and dark band. Alternatively, we started getting the bright and dark point, constructive and destructive interference. So by this experiment, he could able to conclude that light is also behaving like a wave nature. Okay. Now, what type of your conditions we are taking beta? We are taking a monochromatic source of a light of your single wavelength, We are taking the light of your single wavelength. S1, S2 should be very, very close to each other, so that, and they should be also very narrow towards each other. Okay, like see here. From S1 and S2, when the light was been going, it was going in the form of a spherical wavefront. Again, somewhere we are drawing a tangent. Again, from that one, if I am taking the wavefront, from this one, again, the wavelets will be going like this. Again, if I draw a tangent like this, again, the point on this one will be acting as a secondary source, which I told you in the starting. So he concluded that light does not always travel in a straight line. For small holes and aperture whose diameters are comparable to the wavelength of light, light does not travel in a straight line, he started telling. So light is also what we were wave nature. So by this experiment, he could able to conclude that light is also your wave nature because it started bending at the sharp edges or your holes. Clear? So what is the role of your YDSC experiment? YDSC experiment concluded that light does not always travel in a straight line. For small holes or apertures whose dimensions are comparable to the wavelength of light, then light does not travel in a straight line, but they travel in the form of wave. So that proves the light is also having a wave nature. This is actually YDSC double slit experiment. Like see, from the parent source, the light is been going right now here. So from the parent source, the light is been going. This is light like this. The moment it touches here right now, again from here, the parent sources will be forming like this. And they will be intersecting at a point. Some points they are meeting beta. This is known as of your constructive interference. So we are getting at the central maximum. Then here we are not getting anything. So that is known as of your minima. One crust and one trough, they are superimposing like shouldn't it? If this is superimposing like this, if this one wave plus, if there is another wave like this is your plus A, and this one is your minus A. If both of them are meeting, so what I'm getting better. So this is meeting here right now. This is meeting here right now. This is your plus A and this is your minus A, isn't it? So what is happening? Can you tell me? Plus A and minus A. The resultant will come out for me how much? 0. Another. So if there is a one wave like this, and you are adding to your another wave like this. If this is your A and this one is your 2A, both of them are superimposing, so we are getting like that now. This one will become for me 3A. So this is known as of your constructive interference. Clear? Clear, beta? So
Yes,
in
sir.
Slit experiment, the wavelets which have been coming from the S1 and S2 are acting as a secondary source. When they are being meeting, there are some points of your constructive interference and destructive interference on your screen. So by this, you could able to conclude that light is also undergoing the interference phenomena like of your sound, and that proves the wave nature of your light. Let's see, even this diagram, if you can see. We are getting the alternate at the central maxima point, then we are getting a dark point, again minima point, gone like that one. Okay. So this was the basic experimental setup of your YDSC. So go through it once again, beta. So YDSC is what, beta? YDSC experiment is nothing but an experiment which proves the wave nature of a light by his experiment of your YDSC. He took the two coherent sources S1 and S2 from a single parent sources and divided it by using the slits, and the area of the holes of the slit should be almost all comparable to the wavelength of your light. We are using what type of a light, beta? Here monochromatic light of light is being used. Clear for everyone? So this is only the experimental definition of your Young's double slit experiment. Yesterday I have sent you some videos, beta. If you might have been seen that, in that one he will be showing you the interference phenomenon conditions. IDSC experiment. This is also a what do you call that one? Board examination question, beta. That is the reason I'm doing little bit of a detailed derivation, but simple derivation only. You can just understand the derivation. See here, Young's double slit experiment, YDSC. Now what we are doing is we are taking a source here right now. So here this is your source, the parent source. From this parent source, the ray of light is being going, beta. So this ray of light is going like this. And this ray of light is going like this. And at the two holes which has been kept in front of that one, this is a cardboard with the two holes of S1 and S2. This S1 and S2 are called as of your secondary sources. S1 and S2 are called as of what, beta? Secondary sources. S1 and S2 are secondary sources. Okay, S1 and S2 are your secondary sources. The moment that the ray of light is going from S1, S1 is traveling the form of a blue light and reaches somewhere at a point P on the screen. In the same time, the wavelet from the S2 is also traveling in the form of your wave, and it is moving towards the point P and meeting at a point P. Now tell me, is the time taken to reach from S1 to P and S2 to the P is the same or different? Because the distance between them is different together. S1P is less and S2P is greater here. So here I have written here. S2P is greater than S1P. So obviously time taken to reach that point P will be slightly different. And there is also a path difference there. Even though if they are meeting at the same time, but the distance between them will be what? Different. That means the time speed of the first one should be different and the speed of the second one should also be your different. The distance between S1 and S2 is nothing but D. That means from this center to the S1, the distance is nothing but how much? D by 2. And from this D center O to your S2, the distance is again here how much from your D by 2. Okay. The distance between the screen and the slits, these are nothing but of your slits. The distance between slits and the screen is nothing but capital D. Okay. So the waves which are going from your S1 will meet somewhere at a point P, and the wave which is going from S2 will meet somewhere at a point P. In the same way, one more wave might be meeting somewhere at a point of your Q, isn't it? So the two waves are being coming in the arrow mark I have written, you see. So that wave is coming like this and meeting at this point, and this wave is also coming like this and meeting at this point. Like this, infinite number of waves have been coming from S1 and they are meeting on the screen. So we are getting alternatively bright and dark, bright and dark, and bright and dark. And you know that already we have drawn the FVD for this one. The central will always get as a central maxima. Then above we are getting one first bright, and below also we are getting the first bright. Between the central maxima and the first bright, there is a first dark like this. Okay. Is the experimental setup clear beta? Is the diagram అర్థమైంది అందరికీ? అర్థం కాకపోతే అడగండి, సార్ చెప్తాను మళ్ళీ. First, from the parent source, we are keeping a cardboard beta in front of that one, and for the two cardboard, we are making two pinholes, so two paper laga anukondi. Take a paper, keep a torchlight in front, or like a what you call a small bulb, LED bulb in front of that one, and make it two holes from that one. So the moment you make a holes from that one, the light from the two holes will be going out. You might be seeing that one, isn't it? So that's the situation. The distance between slit and the screen is capital D. The distance between the sources S1 and S2 is nothing but of your D. So consider two coherent sources of light S1 and S2, which are being placed at a distance of your D, and the screen is being placed at a distance of what? Capital D. P be the point on the screen at a distance Y from the point 4. See, O to P, the distance in the diagram is given as of your V. Exactly opposite to the center of the two sources, that is S1 and S2. So what you're doing, let P be the point on the screen at a distance of Y from the point O, exactly opposite to the center of your two sources, S1 and S2. If Y is the path difference between the light waves reaching at a point P beta from S1 and S2, then what is the path difference? Means what you'll write beta? This X is the path difference. Like if above is 5 and below is 10, what is the difference between them? 10 minus 5, 5 is the path difference on top. So how to write that path difference X from the given diagram? X is equals to S2P minus of your S1P. ఇప్పుడు మీకు ఈ డయాగ్రామ్ లో కనిపించేవి ఈ యాంగిల్స్ అయితే ఉంటాయి చూడండి, ఈ టీటా తీసుకున్నాం చూడండి ఎల్లోతో, దట్ ఈస్ లైక్ 2 డిగ్రీ 3 డిగ్రీ 4 డిగ్రీ, అంతే. ఇంత పెద్ద ఉండదు, 30 డిగ్రీ 60 డిగ్రీస్ ఉండవు, అవి చాలా తక్కువ యాంగిల్స్ బేసికలీ. సో ద పాయింట్ పి విచ్ ఐఎమ్ గెటింగ్ అబౌట్ హియర్ బెటర్ నియర్ సెంట్రల్ మాక్సిమా కాడ నుంచి ఫస్ట్ బ్రైట్ ఇక్కడ వస్తుందో, యాంగిల్ మేడ్ బై దట్ వన్ ఈజ్ లైక్ సే ఆఫ్ 1 డిగ్రీ ఆర్ హాఫ్ డిగ్రీ ఆర్ సంథింగ్ లైక్ దట్. సో యాంగిల్స్ ఆర్ వెరీ 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 స్మాల్. So if X is the path difference between the light waves reaching at a point P from S1 and S2, then X will be equal to how much beta? X is equals to your S2P minus S1P. ఇక్కడ వరకు అర్థమైంది అందరికి? ఇక్కడ వరకు అర్థమైంది అందరికి? పాత్ డిఫరెన్స్ అంటే ఎలా క్యాలిక్యులేట్ చేస్తాం నాన్న? S2P minus S1P, larger distance minus of your smaller distance. Clear? Now let us try to calculate mathematically the value of X. Now see, in the right angle triangle, so what is the right angle triangle here I'm taking right now? See beta. So S2BP, the right angle triangle S2BP. Where is that one? S2BP. This is S2, this is B, and this is P. So this is like this. Achinda? Okay. So in this triangle, so S2P is how much beta? Capital D. And B2P is how much beta? Y plus D by 2. And this is your hypothesis. So if I'm taking this relation right now, so it will be equal to how much beta? S2P square is equals to S2B square plus BP square. S2B is capital D, B2P is Y plus of your D by 2. The same way, if I'm taking the triangle S1AP, if I'm taking the triangle S1AP, see where is S1AP? This is your S1, this is your A, and this is your P, this triangle. So in this one also, if I'm applying the Pythagoras theorem, this is S1A square plus of your AP whole square will be equal to your S1P square. So A to P is how much beta? A to P will be equal to, from here to here is Y, but this is D. Y minus D by 2 will give me what? A to P. S1 to P is nothing but how much for me? Capital D part of relation. So if I'm writing that one here right now, you see S1AP, S1P square is equals to S1A square plus AP whole square. S1A is D square plus A to P is Y minus D whole square. Now we got S1P and we got S2P. Now take the difference of that one. That is S2P minus of your S1P square is equals to. So that will be equal to your S2P is about what? D square plus Y plus D by 2 whole square minus S1P is D square plus Y minus D by 2 whole square. This D and this D will be gone here right now. So if I'm writing like this in the form of A square minus B square form, what I can write? S2P plus S1P into S2P minus S1P. That is equals to Y plus D by 2 whole square minus Y minus D by 2 whole square. Okay. Now since S2P and S1P is equals to your X. Okay. since your S2P minus S1P is equal to X. So I can write this S2P minus S1P as of your X. So S2P plus S1P into your X will be equal to. So this will become for me how much better? This is your 4y into D by 2. Okay, na? Is that clear? Is that clear?
Yes, sir.
Isn't it? So this one will become for me 2y into D. So X will be equal to how much better? 2y into D divided by S2P plus S1P. So this is your path difference. But in practice, the point P is very close to the center of the screen. So we can write at that time S2P will be equal to S1P and that is equals to capital D. So X will become for me 2y into capital D divided by D plus D, that is 2D. 2 and 2 gets cancelled. So we are getting the first maxima at what distance beta? X path difference value is equals to how much for me? Y is equals to, X is equals to Y into D by capital D. What is Y beta? What is Y here? Can anyone tell me what is Y? Y is the point of maxima or minima on screen. I don't know whether that one, isn't it? So path difference is how much for me? Or X is equals to Y into small d divided by capital D. This is very, very important formula. Okay, what is capital D beta? Capital D is equals to distance between screen and your slits. Small d is what beta? Small d is distance between slits. Okay, and X is nothing but path difference. X is equals to your path difference. So path difference formula is how much for me? Y, X is equals to Y into D divided by capital D. If you see this diagram very carefully, so here right now see, with respect to the theta, whatever the angle I'm taking, so this angle, this one, and this one. If I take the tan theta from this triangle beta, so tan theta will be equal to how much beta? Y by capital D. So that means X is equals to how much for me beta? D into sin theta, EX on the other. E D ni resolve చేయండి. So what I'm doing is I'm resolving this D. I'm resolving this D. If I'm resolving this D, so wherever is theta, that side will become cos theta beta. So this is your cos theta, this is your sin theta. Okay, I'll draw the diagram. You see, this is your D beta. Understand? This is your D, and here is 1 point, and here it is 1 point. Resolving. So this will become for me D cos theta, and this will become for me D sin theta. And here is right now from here to your X. So this X will be equal to this D sin theta beta. So X is equals to D into sin theta. So X is equals, as theta is very, very small, so sin theta will be equal to your tan theta. So X is equals to D into tan theta. All right, the value of tan theta from the given figure beta. So this is your theta, this is your Y, and this is your D. So tan theta is equal to how much for me? Y by D. So this is your D into your Y divided by your capital D. So this is your X. So path difference can also be written in one single step beta. X is equals to D into Y by your capital D part of it. Clear? So path difference formula in the X is equals to Y into D by capital D. So Y is a point of either maxima or minima on your screen. Now if I'm talking about for maxima beta, for maxima we know path difference is how much? E and lambda. So you take Y into D by capital D is equals to N into lambda. So Y is equals to N into lambda into capital D by small d. Okay, so this is for your nth bright point. This is for your nth bright point for definition. Okay, so general formula is how much for me? Y is equals to your n into lambda into capital D divided by your small d. If I'm taking n is equals to 0, we are getting first maxima at central maxima. Then n is equals to 1, first bright. N is equals to 2, second bright, like that. Now for minima, what is the path difference I should take, beta? X is equals to 2n plus 1 lambda by 2 or 2n minus 1 lambda by 2. If I'm taking 2n minus 1 lambda, then you take, you start from 1. In value, if I'm taking 2n plus 1 lambda by 2, you take n is equals to 0. X value already we got. How much is x is your path difference? Y into small d divided by capital D. So we are getting your general formula for the nth dark point as y nth is equals to 2n plus 1 into lambda into capital D divided by 2 into d. Clear? So if I'm taking n is equals to 0, we're getting first dark at what distance? Lambda by 2, d by lambda. That is first dark. Then second dark is at 3 by 2. Third dark is at 5 by 2. Go on like that. Is this derivation clear for everyone? Any doubt in this one? Please let me know.
It's clear.
Clear? Andarki?
Yes.
Simple maths ante inkemi ledu, but you should know what is the central maxima and what is the general condition. Path difference formula enti x is equals to y into small d divided by capital D. For maxima, I told you the formula delta x is n lambda, and for minima, I told you delta x is equals to 2n plus 1 lambda by 2. Delta x anna n x anna okatena, they don't get confused again in that one. So akkada x rashadu delta x ani. So you can even take this one also here, x also. Okay, so x value already I'm substituting that value and simplify that one. So we'll be getting, so this x value I'm substituting here right now. So x is equals to y into d by capital D. Simplifying it, we are getting first dark or nth bright formula as y is equals to n into lambda capital D divided by small d. In the same way, nth dark point is at a distance of 2n plus 1 into lambda into capital D divided by 2d part application. So where is the first dark, second dark content? You can write the notes from this condition. Is it clear for everyone? Is this derivation clear for everyone?
Yes, sir.
In this one. Clear?
Yes, sir.
Yes, sir.
Sure. Okay, now better then. Notes heroes matham chadavandi okasari teesi. So try to complete the notes today and make sure that you make your concepts clear related to your YDSC, maxima, minima, how do you calculate, constructive interference, destructive interference, how do you calculate it. So we'll start doing the numericals based on this one after some applications of YDSC. Okay?
Yes, sir. Okay, sir.
Okay, chalo then. Take care, beta. Bye.